Hi, Assalamualaikum everybody. This is the original Scary Ammi, and I'm here with Kim Langen, who is the CEO of Spirit of Math. She's joining us all the way from Toronto. Are you still in Toronto, Kim?
Yep.
So she's joining us all the way from Toronto, and she's truly a global education specialist, somebody who's looked onto education from a global perspective since she runs Spirit of Math in Canada and it's also in Pakistan. So it's always amazing to have her. And today is one of our maths related live sessions, which is so much fun. So we do these philosophical ones on the meaning of education and online learning. And then we do these math ones. So today we're talking about long division and basic techniques of how to start division, how what are the good ways to teach division, etc. So Kim, I wanted to start with a really basic question that somebody had sent earlier last time and we weren't able to get to it. And the question is something that's actually very relevant. So I thought I'll start with that. And the question is, what do you do when your child hates maths?
Oh,
I thought it was a really good question because there are lots of children who just hate maths.
the first thing is that language hating something. You may want to say, well, you dislike it for something. Pin down what it is that they don't like, as opposed to math as a whole. I guess I'm quite passionate about math because it has such an influence on us and it has such an impact on the future of your children. So, yes, I can understand that question because you understand the value of mathematics. And if they're saying they hate it, well, then that's pretty tough to start with. So, the first thing I would do is say, what is it? Get them to explain to you what is math. And then from there, drill down. What is it that they don't like about it? Because all of math, I mean, it's really interesting. Because I was talking to some kids the other day and saying, we were talking about the Fibonacci sequence and how it's it's in nature. And look at what happens when you count these seeds on a sunflower. And look, it's always in the same pattern. And isn't that cool? And that's math. And then you can see how shapes fit together to form tiles in a room. And isn't that cool? That same pattern happens over and over again. Well, that's math. And if you actually study it more, you find that there's actually mathematics in those patterns. But to start off with, just to even notice the patterns, that's actually math. So, what is it about math that they don't like? And I think just rephrasing that first helps the kids to calm down a bit. Oftentimes, what they don't like about the math is that they're supposed to memorize how to do something. They don't understand why you would do something. The answer has to be perfect. They may not get it. They got the math wrong so many times. They don't want to memorize the facts, or they're having a hard time memorizing the facts. I mean, that's all. Those are all the different reasons or things that they're understanding. So get their understanding first. If it is that they don't like the calculations, then work on them on getting some automaticity with the calculations. And don't start with big amount, just start with a little bit and have them celebrate the little successes. If they see, look, now I know what 2 times 3 is 6 right away, or 3 times 4 is 12 right away, or 6 times 4 is 24 right away, and 3 times 8 is also 24 right away. Oh, that's cool. 2 times 12 is also 24. Oh, cool. So you need to act excited too. And so often I find too that teachers who don't like math, they often say that to the kids as well. So make sure the teacher is promoting mathematics as something fun and something that kids can do. And sometimes, yeah, it takes a little bit of work, but everything takes a little bit of work. Once you get over it, it's okay. So why does your child hate math? It could be just one of those little parts. Fix that and then get them to see that there's actually some real interest. Can I just go on to another reason why? And another reason why is often math is taught as drill and grill type of thing. You just have to do it because I told you to do it. And so who likes that? And there's no meaning to it. It's just finding these numbers. They don't know why the numbers are there. So look at the way it's being taught. That could be why. And usually when people aren't seeing meaning in something, they don't like it. So that could be why they hate it too. A lot of people also have anxiety around math. And the reason why they have anxiety is because they feel they can't do it, or there's something about it that is stressing them, because there is, it's this one subject in which someone said to me, is there such thing as truth? Well, is 1 + 1 = 2? Yes, there is such thing as truth, and mathematics proves it. So that absolute, sometimes people find stressful, okay? Hello. And so there's lots of reasons. And what it is get them to understand those reasons and understand what it is about those reasons so that you can open that up and help them grow. Yeah.
Okay, and we had a question from last time, which was related to that, and then we can move on, which is on, it was from a mother called Madiha, and she was saying, Hi, Kim. My question is that I know that my son, who's in grade 9, wants to become a doctor, and he will become a doctor, and he comes from a family of doctors. He does not like maths. My husband feels he should still do advanced maths. But I just believe that when he's not going to make maths a part of his life, why is it important?
So you're saying he wants to be a doctor?
Yeah. And
Um,
he comes from a family of doctors.
okay, so if he wants to be a doctor, he's going to have to know the math, because math is in all the sciences. Sorry, there's a lot of math. So what I would suggest for him, because it sounds like he's turned off of it for some reason, I'm not too sure why. Sometimes we just got to do what we have to do. And I'm really sorry that he's turned off of the mathematics. Maybe he should go back, look at what is it that he's not understanding. Why isn't it that he's seeing that is so important? He's going to have to not know just calculations, but know how to use the math when he becomes a medical doctor, or even if he's doing research or he's working with patients. You've got to do it, and you've got to know it. So go back. I would suggest too, if you've been turned off of it for some reason, go back to some younger children's mathematics. And sometimes that helps you to see it from a different perspective. And then, even if it's really easy, just enjoy it a little bit and then go up and go up. I am a little concerned about that comment too. If they want to become a doctor, usually numbers they're very important in medicine. And so for him, I would hope that he would like the mathematics as part of that whole profession, because that's important. And if there's something that he's frustrated about with this math, get to the bottom of it. Try and find someone who really knows what they're talking about. They're not just about procedures, because that could be what's really frustrating him. He just doesn't like all the procedures. He's just told, just do this because you're supposed to do it. And he may be a great thinker, and he's looking for that thinking and that reasoning. So you may need to find someone else to help him out.
Okay.
Okay.
So I think let's move on to today's topic, and then we can, go back to the questions. So the topic is about how do you introduce the concept of division, and then eventually lead children to long division. So, Kim, why did you think this topic was so important? Obviously, you're a maths expert, so there must have been a reason that you recommended it.
Well, oftentimes when looking at mathematics, we miss the most fundamental ideas. And so we just skip into procedures, and we're not really understanding what's going on. And the thinking just to figure this out is so, so, so important. In fact, last night as I was, I was looking out and looking at some of the what other people do for the division and long division, and some of the top ranking videos were actually wrong in their explanations. And I thought, there wasn't really much thought, even though it looked like there was. It still didn't answer some pretty fundamental questions I had. So as you go through this, I guess, yes, we'll explain what division is. but I also want you to listen to how I'm thinking, what my reasoning is, what's going on with what I'm saying, and it's not just here's how to do the mathematics. Because if you can catch that, you can apply that to the other types of math and to any other subject area. Division is on itself, it's fairly simple, but yet it can be quite complex. And so let's get to the bottom of it so you understand. The other reason why, because when we were teaching in Pakistan in one class, my daughter was teaching, and teachers were sitting in the back of the class when she was teaching to the kids, and they were really surprised as to why a simple thing like 2 times 3 is equal to 6. It's not just 6 because there is a reason. And so this is why I thought, well, let's go deeper than just 2 times 3. Let's go into the division and have an understanding for that. Okay?
That makes a lot of sense. So, do you have a PowerPoint or should I go directly to the questions?
You know what? I have a PowerPoint. I'm going to go through this. I'm going to teach you all first, so please listen.
Oh,
And I'm going to teach it as if I'm teaching you. And this is more for adults because I'm going to go a little fast. If it was for children, you go a little slower. And we just also thought it might be nice for parents just to have a sample and a model so that you can use some of these ideas, this thinking, and then maybe apply it to a lot of the other questions. I'm seeing some people are, saying my children are getting mixed up with this and that, and we can talk about those questions afterwards. Okay. So if we could, I guess I can display this. I'll just share my screen and then we can go forward. So do you see an empty screen so far? Yes, okay, super. So I'm going to then start with division. Here we go. Okay, so when I actually said an extension of multiplication. And we're going to talk a little bit about this. It's not the same as multiplication. It is an extension. Division is not something completely new. And this is an important idea too. So if you're teaching your children, well, this is what division is. And you're teaching it as a silo, something very different than what multiplication is, you will have troubles. So the first idea in mathematics is that anything you introduce in mathematics, there should be a connection to another idea in mathematics. So it's not just, I've got to know this now, or I've got to know this now. If you can make those connections, the kids will connect in their brains, and those neurons in their heads will actually connect better, and they'll start to reason rather than just memorize these individual pockets. So it is an extension. Let's look at that, and let's look at why or what's going on. So let's first of all look at multiplication and what it really is. So the problem with often that multiplication, I mentioned it very quickly, is that people will memorize without understanding. So and I hear this so often that, well, it is because it's what it is. And there's other tricks. There's a lot of things. Well, these numbers happen to come together, so that's why it is. So let's look at the understanding, and let's look at the 2 times 3 equals 6. So if kids are saying, well, it's just 6 because it is, well, you want to go back and say, well, what does that 2 mean? And what does this 3 mean? And then why would it equal 6? Because what really you're going to be focused on is this itself, which is an operation, and it tells you to do something with these numbers. So let's look at let's look, sorry, I don't know why this didn't open up. So let's look at the 3, and let's look at this question. This basically, this multiplication is meaning that there's 2 groups of 3. Some people want to say, well, there's 3 groups of 2 as well. And yes, there are. And the interesting thing about multiplication is that you can move numbers around. And with our relocation property, they actually both have an operation sign. But let's not go into that right now. Let's just talk about what multiplication is. We've got two groups of 3 here. So the first group is here, that's 3, and another group is 6. So oftentimes what happens is that people will say, well, multiplication is whoops, let's just go back here. Sorry, something happened. Sometimes people will say that it's an extension of addition. And when you've got saying it's an extension of addition, which is true, you can say that 2 times 3 is really the same as 2 groups of 3, so you have 3 plus 3, which is equal to 6, which is what I've shown you. So notice the extension of the basic concepts. So if we go now to the next one, let's look at division using words. So 2 times 3 is equal to 6, and therefore 6 divided by 3 is equal to 2. We oftentimes what's given is, okay, that's it, period. So you have to know this. Well, why? Why does it work like this? And again, someone will say, well, instead of adding, you're taking away, and start using the subtraction concept. But and we can use that kind of concept, but let's put this into words first. And language is so critical. So here it's saying, how many groups of 3 can you take out of 6? Well, here's 6 right here. And if you take out these groups of 3, and you can take away 1 group of 3, 2 groups of 3, and you're left with 2. That's really what division is saying. Or you could say, how many groups of 3 can you subtract from 6? 1, 2. So I have made it easy by showing you the 2 groups of 3. If you miss using the proper words, you will have trouble. Kids won't understand what you're talking about. They'll be going back to, I just have to memorize. They'll be going back to this whole thing and saying, well, there's something associated with each other, but I really don't know what it is. So if you connect those 2 ideas, and kids will understand the division so much better and what it really is. How many groups of 3 can you take out of 6? You can take 2 groups of 3 out of 6. So if we go to this next idea then, we can say that therefore 2 times 3 is 6, and therefore 6 divided by 2 is equal to 3. Because now what we're asking is, how many groups of 2 can you take out of 6? And you can take 3 groups of 2. So let's look at 6 again. And we've got 1, 2, 3 groups of 2 that you can take out of 6. Okay? So watch that language. Ask the kids to figure it out. Circle the stars, circle the circles, whatever, the squares, whatever you used. How many groups can you take out? Now, the other thing you can do is you can quickly and easily do that with even pencils. If you have 6 pencils, make groups of 2. Boom, boom, boom. And you'll find that they can take 3 groups of 2 out of 6. Okay? So now I'm going to give you more of a long division idea. And this long division idea is, now you've got 43 divided by 3. Now, you could do 43 divided by 3. You could find out all the groups of 3. And you could literally, circle groups of 3 so that, and you can count them all. We're not going to do that. You can, and that's the beginning for young children. And if you teach that with young children, they think, I can do division. And they feel good and they feel proud. When kids are turned off of math, it's usually because they don't understand. They get stressed because they're supposed to get an answer. They don't know what it is. Start them with something very simple, just by circling. How many groups of 3 can you find here? And that is literally division. It's a nice start. So let's look at this a little bit more. And I'm going to do this with I'm going to take this first of all by actually we'll count the the number of groups of 3. And if you count it, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, we've got 14 groups, and notice there's 1 star left over. So basically then, what you say is that there's 14, remainder 1. And what does that remainder 1 mean? Well, you can actually connect that by saying, well, there's 1 left, 1 star left out of a group of 3. So in fact, that remainder 1 means 1/3. And now look, you've actually introduced the concept of fractions without saying much to kids. You can leave it with the remainder 1, but what does that 1 really mean? And that fraction, just for adults just to understand, 43 divided by 3 can be written like that. And for
Kim, we had a question that from Faiza Ali, that isn't this method that you're teaching very time consuming?
It is time consuming to begin with, but then what happens is it becomes, if you set the foundation really well, you're not going to keep doing this every single time. This is just to set the foundation. So thank you for asking, because you've got to get people to understand this isn't just magic, that it equals this, and you're just to do this algorithm. There has to be an understanding first. And if there's no understanding, then people get turned off of mathematics. So there's got to be, and also it is the reasoning behind it, because children are wondering, why would you do this? Why is it equal to that? Rather than just memorizing is the opposite of multiplication. So if you notice, what I'm going to get to next is I'm going to get to the algorithm. But once they see this, there's got to be, okay, it's 14 and 1/3. So how do you get onto the algorithm? Does that answer your question?
Yeah.
Okay. All right. So I'm going to get onto the algorithm now, and we can look at this algorithm a little bit in terms of how you would explain that. So when doing this now, I'm going to do it by hand. You already know that it equals 14 remainder 1 because I'm not changing it. But when you're talking about this, what you'll want to do is you want to say that if you've got long division, this has to be rewritten like this. And when you've got that, everyone, like there's a lot of people who say that kids want to start by dividing 3 into 3 and not 3 into 4. So why is it that you start with the 4? Well, the basic reason really is because you want to get rid of the biggest groups first. So when you're saying 3 into 4, you're actually saying that's 43 is the same. And now this is for you guys. You're not going to have to teach this to the kids all the time, but you'll want to reason through some of what's going on here, because 43 is really 40 plus 3. So when you are doing this, you're saying how many groups of 3 can go into 4, or how many groups of 3 can you take out of 4? And you know that there's one group of 3. How does that connect to this other idea I had here? Well, notice that we're working really with 40, not 4. And also, if you really, where this algorithm came, and it took a while for people to create, and I'm not going to go back into too much detail, but basically you're saying one group of 30 can go into 40. And that's really what this is saying. But you don't necessarily say that to kids because it gets really confusing. But that really is it, because one group of 3 is 3, but one group of 30 is that, if you notice. And so if you subtract that out, and you've used these and we've taken out that one group of 30, what are you left with? Well, you're left with 13 left over that we haven't worked with yet. And that's all these stars. That's where that 13 comes from down there. So now you want to say, well, how many 3s can go into 13? Because now you're working in the units digit. That 3 here is the units digit for that 43. Okay, so how many 3s can you take out? Again, you can use if you know your multiplication facts, then you can do this fairly quickly, because you would say that, well, 3 times 4 is 12. So that's as close to the 13 as I can get without going over it. And if kids, when they're young and they want to know why you got 4, you can say 1, 2, 3, 4. So you've got 4 groups of 3 you can take out. And notice we're taking those out. And that's why you subtract. And what are you left with? You're left with that one lone star. So that's why you say remainder 1. Okay, so the reason why I'm teaching you this right now is so that you understand the connection, that there is a reason why this works. It's not just magic. Kids also have to see that reason, because when they start seeing the reasoning, then they're going to like it a lot more. And they'll see that, oh, there's something to be discovered, as opposed to, I just have to memorize it because someone told me to do this. Okay, so then they can apply it. When we have that, then what we can do is get to a larger one. And I basically put here 114. Sorry, I didn't actually change this answer. We're going to see the answer in a second. But I actually put this here just so that you would see that this is another way. Like, this is much bigger, but it's also the same concept. So again, you have 114, and that's divisible by 3. And so we first of all start with the hundreds unit. Remember, 114 is the same as 100 plus a 10 plus a 4. Okay, so we start with the first one, which is right there. What you want to do, that's hundreds. So how many 300s will fit into 100? Well, 0. We don't usually write that 0 at the beginning, or how many times does 3 go into 1? It's 0 times. I'm not going to write that there. Sometimes when you first start teaching, you may want to just put that there just so that kids know not to start writing on top of there. Okay, now because there's 0 3s, well, 0 times 3 is 0, so you still have 11. So now what you have to say is, well, and this is a subtraction, how many 3s go into a, now, again, if we've got 114, remember that this now is really looking at 110. So you're actually saying how many 30s can you take out of 100 and out of 110 to begin with, and what's left over. So, or 114. So I've actually got groups of 30s here. And first of all, you can see that you can take 3 groups of 30, and that leaves you with 90 left over. And what do you have? You have 10, 24. Sorry, and then, sorry, I'm going to go back because I'm getting a little mixed up with the reasoning as opposed to how you do the algorithm. So you can see, though, that as you're taking this out, what's left over, each time you're going to get smaller and smaller. So the algorithm itself, how many 3s go into 11? Well, three 3s go, you can take out of 11. You're left with 2. Then what you have is a 24. So how many 3s can you take out of 24? And that's really what's left here. And the number of 3s that you can take out of 24 is 8, because 8 times 3 is 24, and you're left with 0 at the end. And you can actually get kids, if they're wondering, how do you do that? You can again do this, and you can get them to circle it if they need to. If they need proof, some kids need proof. So 114 divided by 3 is literally, is just 38. Okay, so so what you've got there then is the algorithm, but you also have to understand where this all comes from. So when we then look at the algorithm for something much larger. And if you're going to do something like this, now 6536.00, you can use the same idea. Now what happens is that estimation becomes critically important for division. And if kids don't have that ability to estimate, they're going to find this really, really tough. So estimation is, well, we can't put 12 into 6 to begin with. So how many times will 12 go into 65? Knowing your times table is bottom line is so important for knowing it. So if you know that 12 times 5 is 60, now you've got an estimation. And so you can say, well, it's going to go approximately 5 times, and 5 times 12 is 60. So then I can subtract that and see what I have left to work with. Got the 5, I bring down the 3, and now I've got 53. So now how many groups of 12 can you take out of 53? Well, you can take 4 groups of 12 out of 53, and that's 48. And if you take those 48 out, how many you're left with? 5 from there, and then you bring down the 6. So now you can say, well, how many groups of 12 can I take out of 56? You can still only take 4 groups of 12 out of 56. And what you're left with is 48. And that leaves, so well, 4 times 12 is 48. And what you're left with when you subtract is 8. And then you can bring down the 0. And you can say, well, how many groups of 12 can I take out of 80? And at this point, you have to make sure that kids understand that you've taken whole parts out before this. Now you're at the after the decimal, and you have some remainder. In fact, you may want to, like, sometimes you just finish with that 8 being the remainder, and you just say, okay, it's 544, remainder 8. But when you get to the next level, you're going to say, okay, we also need to do decimals. So how many groups of 12 can you take out of 80? And you can take 6 groups of 12 out of 80. And 6 times 12 is 72. And if you subtract those two, then what you get is 8 again. Whoops, there you go. You get 8 again. And so then you bring down another 0. And then you end up with how many groups of 12 can you take out of 80? Well, 6 is the maximum number. 6 times 12 is 72. And you'll find, and the kids will find, that they keep getting the same number. So now this again is where mathematics becomes interesting. It's not just, did I get the answer? Why is that 6 repeating? What's going on? And if the secret to that answer, and they need to discover this. So when they discover that the secret to that answer is what is happening down at the end, that you keep getting this, the 0 and the remainder 8, and then 0, you bring down the 0, and remainder 8. Oh, why is that happening? You get the kids to discover this and to understand. So really then, what you've got here at the end, when the kids are finished this, they should be able to write something like this. It's 6536 divided by 12 is equal to 544. And I said they could have said remainder 8, or they could have said 544.6. And that's repeating, so you can put a line on top or a dot on top. Now, to connect that, and this is why I love to connect ideas for kids, the same concept is 6536 divided by 12 can be written like that. And when you do that, you get 544, and your remainder is 8/12. And if you wanted to reduce that or write 8/12 as a decimal, you could. You could simplify that to simply 2/3. And then you can have, or you can write it as a decimal, again, 6 repeating. Okay, so I hope you can see that there's a lot of connections here that we've got, and that you've got, and that this is there's so much to division that now goes into so many other areas of mathematics. If kids don't understand division, they won't be able to enter into the other mathematics well, and they're going to get frustrated. So why. That's why I thought this was an interesting one. I hope that's
Yeah, that was really fascinating, really fascinating. So we have a question from Nasir Khan, who wants to know, at what age should a child be able to do long division on their own?
um, well, it depends on how big the long division is. You can start at a young age. We actually found that we could start with grade ones with very, very basic long division. And that would be, we always start with a 1 by 1, just so they get used to seeing the algorithm, how it's written out. So it's even, we teach division first, and then we show them this is the way long division looks. And they usually think, well, why do we have to do that for such a simple question? But really, the reason is so that procedure and even that format with that way that long division is written, it looks so strange. And to introduce it when they're younger, that strange look for the long division, you can start very young age with very little to do with the calculations. And then you add on, and you can do a 2-digit divided by a 1-digit number. Be very purposeful with the types of questions you give so that you don't have the complexity to begin with. They learn the procedure. The procedure itself is repeated, repeated, repeated. So it's not tough as long as you use easy numbers. You want them to be successful first with the easy numbers. Get that procedure done so they kind of have fun, okay? And then you start, let's now push it with the calculations. Okay, so
Yeah, that makes a lot of sense. Um, Sorry, were you saying something?
well, I was just going to say, what age should they be able to do long division on their own is a key part of this too. They can even do it on their own when they're young if you give them something simple. So look at the numbers you're using, and it should divide in really nicely to begin with. And then when they get to an older age and they get harder numbers, they know the procedure. And all what it becomes that next is, do they have the calculations down? So make sure before you introduce them to really tough long division, fill in the gap with making sure they have the automaticity of number facts, that they have that or that they understand multiplication period and they have the facts for multiplication. Don't introduce division until, like the complicated division, until they've got those number facts for multiplication down really strong.
Okay. We have a question from Kulsum Nazir on, why is division so much harder than addition or subtraction? And also, should division always be taught at the end? So I think you begin with addition, subtraction, multiplication, division. Is that the right way to go?
Okay. Addition is easy to teach because the concept of something and another together makes this. And that's a very simple concept to understand. And then from there, you go backwards and you say, well, if we take away something, what are you left with? That concept is also fairly simple. And kids understand that at a very young age, because if they want something, they don't want it taken away from them. So that subtraction concept is understood quite simply. When you get to groupings, and I'm going to get this concept, it actually, the complexity in the brain, so groupings for multiplication requires an understanding of groupings. So we've got 2 groups of 2, which is equal to 4. And if kids don't have that understanding of a grouping, because that's an extra complexity. So now you're adding those together. So you've used the addition, 1 plus 1 comes together. Then we say 2 groups now come together, and that's multiplication, really. Okay, so notice that you're adding on to the complexity of the conceptual, like the concept itself of coming together. So when you take away, which is really what division is, it's the same as subtraction. It's a lot to understand. And if it's taught too quickly, and if it's taught just as the opposite of multiplication, kids they're going to be turned off, and they won't understand what division is at all, except that it's the opposite of multiplication. It doesn't give understanding. That's a rule. And that's why kids will find division hard. Division is also hard because simply it requires a higher level thinking of estimation. And estimation requires a lot of different skill sets and a lot of skills. So estimation is tough, and it requires it for division. You've got to work backwards from that multiplication, and you've got to know, well, how far up can I go? You've got to put a lot together. Division's tough.
That makes sense. Faiza Ali is saying that I can't do division mentally. So, how important is it to do division like mentally?
Okay, the reason why you probably can't do division mentally is because probably your multiplication facts aren't strong enough for you to be able to do the division easily. Okay, so if I had said 6 divided by 2, right away for me, I'm thinking, well, 2 times what equals 6? Well, it's 3. So if I didn't have those facts in my brain and I didn't know that, then I would not have been able to do that division. The other reason why, the other reason why division is hard is because it's multi-complexity in your brain. There's several steps you have to do. So I can't do division mentally. I would say practice. And is that essential? Well, define essential. Food is essential. Water is essential. Loving people around you, I believe, is essential. And having a bit of a challenge, I also believe our brains need that and to be functioning well. But it's not essential for you to live with, but I'll tell you what, it'll make your life a lot easier because it's applied in so many different areas. And as a mother, and also when you are in charge of looking after your home, you'll need to look after the money numbers in a way and understand, if I give out this and this to so many, 3 different people, how much is that? It'll make your life so much easier, and you'll understand why things aren't working as well as they should be. So it's not essential, but it certainly will give your life a break and make things a lot nicer for you.
Right. Okay. The next question is, how early should the concept of division be introduced to you?
The concept of division, let's look back into, let's go back to that basic concept of what is division. That basic concept can be taught very, very young age. How many groups of 3 can you take out of here? There's 4 things. How many groups of 3 can you take out? Oh, I can take out 1 group of 3. Awesome, very good. You just did division. Okay, so it's 1 group of 3 with a little piece left over, and that remainder, that's called a remainder, remaining, left over. So start with some of the language when the kids are young so they understand, like that concept itself can be taught at a very young age without actually saying, look what you did on a piece of paper. If you're talking about just introducing division to kids on a piece of paper, where I'm seeing it introduced around the world is grade 3, grade 4, and it's people are scared to introduce it before that. I say introduce the concepts at a much younger age. Just start when they're little; they can do it. I mean, it's just that concept I just talked about. If you can get that concept through to them when they're learning the algorithm later on, it's going to be so much easier for them, and they'll just say, "Oh, yeah, I already know how to do this." And they won't be going, what? I've never heard that language before. I don't know what you're talking about. That's usually where the problems are. Okay.
Okay, we have a question about how someone's sons know their tables but don't like division. So why is it, are we not teaching division properly? Like, why is it that multiplication, maybe because they memorize the multiplication facts, are so much easier than division. Like, are there any division facts to be memorized? Like, why is the transition from multiplication to division? Like, that seems to be a pattern in the questions. And I know from talking to moms and being a mom that division is harder. But why is it so?
Again, it goes back to the complexity and the estimation. It's not just memorization. You have to estimate a little bit to get that division fact out, because it doesn't, like if I said 48 divided by 8, divided by 4, you can say 12 if you know that multiplication fact. But if I say 49 divided by 4, you can say 12 remainder 1. So you actually have to do that extra adding up. The complexity is that much harder. Most kids don't like division to begin with, okay? Now, what we have found when we're doing our multiplication, short multiplication, and then our short division drills, what we have found is that the kids, they'll finish the short multiplication, they have all the facts down, they can do, a certain amount, 73 by 1 digits within 10 minutes, get them all correct, and then they go to the short division, and they think this is going to be so much harder. And they still have 80 questions to do in 10 minutes. It's a 3-digit divided by a 1-digit. And when they start with, it's slower. But actually what ends up happening is a lot of kids will say, I find this division easier afterwards. And so their brains start working a little bit backwards. It's not wrong. It's just that they're able to have that flexibility. And once they start doing it a lot and they see that their speed is building up with just a simple 3-digit divided by 1-digit, and they're able to do them really quickly, you'll see that, and we don't get them to do long division for all of those. They have to do it short division in their head. What are they carrying? And just write down the answer. And they get it. And it's actually interesting because they actually get it faster. It's maybe the exercises that you're doing too. But division is harder in your brain. It's the complexity. There's more steps to answering.
Yeah. Okay, Aisha Hassan has an interesting question. How can you diagnose children with dyscalculia?
Oh, I'm not a real expert in that. So what this is kids who get numbers mixed up when they're calculating. They write them down wrong. They're really struggling because they can even write them backwards. So instead of saying 43, they write down 34, for example. And it's similar to dyslexia, but it's slightly different, just for people to understand. To diagnose it, I would get someone who does understand this, but you may want to watch what's happening if they say 43 and they write down 34, or vice versa, and they keep doing it. I mean, I do that every now and again, and sometimes I'm wondering if I have that. But I mean, it's who knows, I might. But I think what's important is that you just keep noticing: is it affecting them to the extent that they're getting too many questions wrong, and it's affecting their success? Then you start questioning. Then you can go to an expert and find out. Look it up on the internet too. There's lots of different things you can do, little tests that they give you that would at least give you an indication of whether you should be worried or not. Interesting question. Thank you.
That makes a lot of sense. So Nagin is saying that, maths was always my favorite. How can I get my children to love maths?
Thank you, Nagin. Okay. Again, it's your passion. If you're passionate about something, they'll like it too. Don't introduce too much at one time. Make sure that you build on the ideas. If you introduce too much at one time and just tell them, memorize, you got to know this, without understanding, and they're frustrated, they're going to get more frustrated. And then what happens when they get more frustrated? Their anxiety goes up. And if this is your usable memory, when anxiety comes in, it goes like this to your usable memory. And your usable brain power, basically. And this is why when people have math anxiety, they do so poorly, is because they're not using their whole usable brain to calculate and to use it for mathematics. So keep it fun is my biggest thing. Show your interest in it. Show them some neat things. The other thing is get them to discover some things. Look at this. Now, what can you do with that? Oh, do you see a pattern? Like there are even simple patterns with just multiplication and that you can look at. Like even the 2 times table. Look what happens. It always ends in a 2, 4, 6, 8 or a 0. Oh, cool. Get them to discover it. Don't just tell them everything. Because once you get that sense of discovery, then the kids will like it more. The other thing to do is do make sure they have an automaticity of number facts so that they can enter into the mathematics. And again, start with simple facts and faster so they feel the joy of getting it faster. We all like that little adrenaline rush. So, so your passion, but go slow. I think one of the things that many parents and teachers do is they teach something too complex too quickly, and they demand, come on, you gotta get it. And instead of sitting back and going, what is it that you're not understanding if they don't understand it? And then delve down and show them it's okay you don't understand, but let's figure this out. And it's figuring it out, which is just as fun as it is doing the math.
That makes a lot of sense. So Farah Kamran is saying that, teachers don't give shortcuts to children, they don't tell them tricks. And so her daughter gets very confused doing maths, and she believes in Pakistan the school syllabus is very difficult and they want to put everything at once into.
Okay, so I'm not too sure that the curriculum is difficult per se. I would say more the way that it's introduced could perhaps be more understanding for people, or it could be more like a stepping stone for the kids so that it makes sense. Because for the kids, when introducing new ideas in mathematics, it should appear to be obvious to kids. And if it hasn't appeared to be obvious, then you're going to get things like this, which means really, how was the curriculum developed? Well, it started here, and then it goes forward. So that's really what I'm seeing is happening. I know that many people have told me they've just memorized all the answers to the questions. They do the same questions year after year. So all they have to do is get those questions and they memorize it, which is really unfortunate because that's not doing math. That's memory work.
Yeah, absolutely. Okay, so the idea of Botners, and there were a number of questions on Botners. Do you think this is the right way to teach? Is it important to teach them these tricks, or like is this not a good way to teach? I remember learning like the Botners and the tricks when I was learning division.
Okay, so BODMAS, are you, because we don't use quite that. We talk about BEDMAS, brackets, like the order of operations. Is this what this is used for? Or what's this used for? This is interesting.
What does Botners stand for? Brackets?
Oh, okay,
Yeah, then I think it's brackets of division, multiplication, addition, subtraction.
so that's your exponents. So what we use in North America is BEDMAS, and brackets, exponents, division, multiplication, addition, subtraction. So the reason why this was brought up, okay, so you just so everyone understands, you're using a different word for that exponents than we do, and that's fine. It's the same idea. Reason why this is brought up in mathematics, when they started looking at how numbers work and having an understanding of how multiplication works and division and so on, they said, you know what? There is an order to do these calculations because otherwise you're not dealing with numbers as numbers. So if you think about the number 6, 6 is 2 times 3. So that's another way to write 6. So why am I telling you that? Because if you had a 2 times 3 plus a 4, or 6 plus 4, you could do 6 plus 4, but if you had 2 times 3, that really is 6. That's just the 6 split to show you all the different components of 6. So you put those together first, and you've got the 6, but it was introduced, first of all, as a 2 times 3. So you have to do that one before you can do the addition. Otherwise, you're actually not working with numbers in the way that they work and understanding really what numbers are all about. Now, the question is, it's difficult for them to understand. Again, it comes back to how is this being introduced? Because I'm questioning that's actually a fairly straightforward. Again, it should be introduced with something simple. You add on the next part, you add on the next part. If kids know how to move numbers around and how to calculate with things before they get to bad maths, then when bad maths comes in, it should be quite simple. Personally, I don't like using BODMAS or BADMAS, and the reason um, is saying that addition comes before subtraction. You can do subtraction before addition if it's simpler to do a subtraction part first. So, and also you can divide out before you do all the multiplications if there's a lot of multiplications and divisions all together. So it's understanding numbers and how they work again, and operations. So why is it difficult for them to understand? Again, it's how is it introduced and how is the mathematics given to them?
Okay, we're almost are out of time, so we still have other questions, but I think you've covered all the essentials. So thank you so much, Kim. I felt like I was back in my school days learning division.
Good.
And
Okay.
really, really interesting. And maybe if we were all taught division better, we wouldn't be so scared. Sorry, were you saying something?
I was going to say thank you very much for this time, everybody, again, and for all these good questions. Please send us even more questions. If there's little things that just bugging you, it's always important to get them done. And I appreciate being here, and I love talking to you guys. So thank you so much.
Thank you. Bye-bye.
Bye.